Installing a 120/240 volt service or breaker panel on an unfinished basement block wall requires specific techniques to ensure safety and compliance with electrical codes. Direct mounting is generally not permitted. The panel needs to be spaced away from the wall to prevent arcing and potential fire hazards. Several backing methods can be used to achieve the required spacing. Firstly, consider using furring strips or blocks. Attach furring strips or blocks to the wall using masonry screws or bolts. Then, mount the panel to the furring strips or blocks with appropriate screws, ensuring the required spacing from the wall. Secondly, an electrical mounting panel designed for block walls can be installed. This panel provides a flat surface and studs specifically designed for mounting a breaker panel. Thirdly, a backer plate can be fabricated. Cut a piece of plywood or metal to fit the size of the panel. Attach the backer plate to the wall using masonry screws or bolts and then mount the breaker panel to the backer plate. Spacing requirements are critical. The panel must have a minimum of 0.5 inch or 12.7 mm clearance from the wall. This clearance allows for proper ventilation and reduces the risk of arcing. Always consult local building codes and electrical standards for specific spacing requirements in your area. When working with electrical panels, several other considerations are important. Firstly, electrical wiring. Run the necessary electrical wiring from the service entrance to the panel, ensuring the wires are properly sized for the intended loads. Secondly, knockouts. Use knockouts in the panel for cable entries, ensuring that appropriate connectors are used to secure the cables. Thirdly, grounding and bonding. Connect the panel to the grounding and bonding system of the building. This is essential for electrical safety. Finally, inspection and approval. It is absolutely necessary to have the panel installation inspected and approved by a licensed electrician or building inspector. Electrical installations can be dangerous. This ensures compliance with safety standards and proper functionality. Selecting the right location for the electrical panel is an important first step. Consider accessibility for maintenance and future upgrades. Ensure that the location is dry and free from potential water damage. The National Electrical Code, or NEC, provides guidelines for working clearances around electrical equipment. Typically, a minimum of 36 inches of clearance in front of the panel is required. This clearance ensures safe access for electricians to perform maintenance or repairs. Proper grounding is critical for electrical safety. The grounding system provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. The NEC specifies requirements for grounding electrode systems, including the use of ground rods, metallic water pipes, and concrete-encased electrodes, often referred to as UFA grounds. Bonding is another important aspect of electrical safety. Bonding connects all metallic parts of the electrical system, such as conduit, enclosures, and equipment, to create a low impedance path for fault current. This helps to minimize voltage differences and reduce the risk of electrical shock. The NEC provides detailed requirements for bonding, including the use of bonding jumpers and appropriate bonding methods. When running electrical wiring to the panel, use the correct type and size of conductors. The size of the conductors must be adequate to carry the intended load. The NEC provides tables that specify the ampacity of different conductor sizes based on the insulation type and installation conditions. Proper overcurrent protection is essential to prevent damage to the electrical system and reduce the risk of fire. Circuit breakers and fuses are used to protect circuits from overloads and short circuits. The NEC specifies requirements for overcurrent protection, including the selection of the appropriate size and type of overcurrent device. When making connections inside the panel, use appropriate connectors and ensure that all connections are tight. These connections can cause arcing, overheating, and potential fire hazards. Use a torque wrench to tighten connections to the manufacturer's specified torque values. Label all circuits clearly and accurately. This will make it easier to identify and troubleshoot circuits in the future. Use a circuit directory to document the purpose of each circuit breaker. Keep the panel clean and free from debris. Dust, dirt, and other contaminants can accumulate inside the panel and cause overheating or other problems. Periodically inspect the panel for any signs of damage, such as corrosion, loose connections, or damaged insulation. If you find any problems, have them repaired by a qualified electrician. When working with electrical panels, always follow safe work practices. To energize the circuit before working on it, use appropriate personal protective equipment such as gloves and safety glasses, and never work alone. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Working with electricity can be dangerous. It is important to take all necessary precautions to protect yourself and others from electrical shock and fire hazards. Remember to consult the latest edition of the National Electrical Code and local building codes for specific requirements in your area. Code requirements can vary depending on the location and type of installation. By following these guidelines, one can install a 120/240 volt service or breaker panel on an unfinished basement block wall safely and correctly. Always prioritize safety and consult with qualified professionals when needed. The NEC Table 310.15b16 details the allowable ampacities of insulated conductors rated up to and including 2000 volts. This table is critical for selecting the correct wire size based on the expected current load and the conductor's insulation type. For example, a copper conductor with THHN insulation, commonly used in residential wiring, will have different ampacity ratings depending on its size, such as 14 American wire gauge or AUG, 12 AWG, 10 AUG, and so on. Ensure proper conduit fill when running multiple conductors within a conduit. The NEC specifies the maximum percentage of conduit cross-sectional area that can be occupied by conductors. Overfilling a conduit can lead to overheating and insulation damage. NEC Chapter 9 provides tables that specify conduit fill requirements based on the size and type of conduit and the number and size of conductors. When using non-metallic sheath cable or NM cable, such as Romex, follow the NEC guidelines for securing and supporting the cable. NM cable must be supported at intervals not exceeding 4.5 feet and secured within 12 inches of boxes, cabinets, and fittings. This ensures that the cable is properly protected and prevents strain on connections. Use appropriate cable clamps and connectors when terminating cables at electrical boxes and panels. These connectors provide a secure connection and protect the cable from abrasion and damage. Ensure that the connectors are properly sized for the cable being used and that they are installed according to the manufacturer's instructions. When installing ground rods, follow the NEC requirements for depth and spacing. Ground rods must be driven at least 8 feet into the earth and spaced at least 6 feet apart. This ensures that the grounding system is effective in providing a low impedance path for fault current. Use a listed ground clamp to connect the grounding conductor to the ground rod. Ensure that the clamp is properly tightened and protected from corrosion. When connecting to a metallic water pipe for grounding purposes, bond around any insulating sections of the pipe, such as plastic fittings or couplings. This ensures that the entire metallic water pipe system is effectively grounded. Use a bonding jumper to connect the two sections of the pipe around the insulating section. When installing a subpanel, ensure that the neutral conductor is isolated from the grounding conductor at the subpanel location. The neutral conductor should only be grounded at the main service entrance. This prevents circulating currents and reduces the risk of electrical shock. Use a 4-wire feeder to supply power to the subpanel, consisting of 2 hot conductors, a neutral conductor, and a grounding conductor. When working with 3-phase power systems, ensure that the phase conductors are properly identified and labeled. Use color-coded tape or markers to identify the different phases, such as A, B, and C. This helps to prevent accidental phase-to-phase shorts and ensures proper operation of 3-phase equipment. When installing lighting fixtures, follow the NEC requirements for mounting and wiring. Ensure that the fixtures are properly supported and that the wiring connections are secure. Use appropriate wire connectors and ensure that the conductors are properly insulated. When installing receptacles, use tamper-resistant receptacles in areas where children are likely to be present. These receptacles have a built-in safety mechanism that prevents objects from being inserted into the slots, reducing the risk of electrical shock. Follow the NEC guidelines for GFCI protection in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. GFCI receptacles or circuit breakers can detect ground faults and quickly interrupt the circuit, preventing electrical shock. When installing electrical equipment in damp or wet locations, use equipment that is listed for those environments. These equipment are designed to withstand moisture and prevent electrical shock. Use weatherproof enclosures, fittings, and wiring methods. When working with electrical panels, be aware of the potential for arc flash hazards. Arc flash is a dangerous electrical explosion that can cause severe burns and other injuries. Wear appropriate personal protective equipment such as arc-rated clothing, gloves, and face shield when working on energized equipment. Follow safe work practices to minimize the risk of arc flash. Before working on any electrical equipment, verify that it is energized using a voltage tester. Test each conductor to ensure that it is not energized. Use a reliable voltage tester that is properly rated for the voltage level being tested. Always follow lockout/tagout procedures to prevent accidental re-energization of the circuit. Place a lock and tag on the circuit breaker or disconnect switch to indicate that the circuit is being worked on. Remove the lock and tag only after the work is completed and the circuit is safe to re-energize. If you are unsure about any aspect of electrical installation or repair, consult with a qualified electrician. The electrical work can be dangerous, and it is important to have the knowledge and skills to do the work safely and correctly. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years, so it is important to stay current with the latest edition. The NEC is available for purchase from the National Fire Protection Association or NFPA, and is also available for review at many public libraries. The authority having jurisdiction, or OJ, is the local agency that enforces the NEC and other electrical codes. The AHA may be a city, county, or state government. It is important to contact the AHA to determine the specific electrical codes that apply in your area. Electrical permits are typically required for most electrical installations and repairs. Contact the AHA to obtain the necessary permits before starting any electrical work. Electrical inspections are typically required after the electrical work is completed. Contact the AHA to schedule an inspection. An electrical inspection ensures that the work was done safely and correctly and that it complies with the applicable electrical codes. Maintaining a safe electrical system is an ongoing process. Periodically inspect the electrical system for any signs of damage or wear. Repair any problems promptly. By following these guidelines, one can ensure that their electrical system is safe and reliable. Always prioritize safety and consult with qualified professionals when needed.